everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about question bank discussion on the topic Fourier transforms. In detail, we will discuss Fourier transforms regarding definitions and terminology, how they are subject to the field of the transformation of Fourier, in which finite, infinite, all we are going to discuss. That the question bank discussion, the question bank which is prepared in such a way that is short answers, they are under part A, and the question bank long answers part B. Short answers 20 questions are playing the role. In long answers 20 questions are there. The last one, problem solving and critical thinking. Little bit beyond the syllabus or tough, the way of thinking about the problems will be there in part C. And the question bank, how it is prepared. It is completely following Bloom's taxonomy. Following this condition of the Bloom's taxonomy, the action verbs which are used in question bank completely all the three divisions. Yeah, this is Institute of Aeronautical Engineering, the Autonomous College. This is the actually the sample which has taken for the branch of aeronautical engineering. This course, mathematical transform techniques, which is applicable to aeronautical, EEE, easy, and civil, mechanical, all these branches. This course, mathematical transform techniques, the course code is AHSC07. So, this is actually in the second semester, this syllabus being taught. The first one branch, which is the example which is given here, completely. This is actually prepared by Dr. S. Jagadha, myself, Associate Professor. This is the complete syllabus UG 20 regulation. So this what we discussed, actually the format, just the previous slide. The question bank answers completely according to the syllabus. The Bloom's taxonomy, the levels, 6 levels are there. The first level is remember. That is, the questions, whatever is asked in the question bank, the remember the level, the first level it follows. That is, just recollecting what we learnt, recalling, the answer will be written. Just any formulas are there. What we remember, that we will be writing. Mostly such type of questions will be playing in the role remember. The next one is understand. That is, remember plus the recalling work is over, how far we understood. Understanding the problems will be done. So the second level also questions are dominating in question bank. The next one is apply. These two, remember and understand, recalling the formulas and understanding the concept, we will apply those defined formulas in the problem. That is apply. So totally our question bank, which these three levels covering, which is prepared. But according to Bloom's taxonomy, the fourth level is analyze. That is, after application, this is little bit high level. But the syllabus which is taught for the first year BTech students, so which is prepared according to Bloom's taxonomy, these three levels covering the questions are dominating. Fourth level is analyze. Fifth level is high level, evaluate. The last one is create. So our question bank is only these three levels containing questions are there. Yeah, this is the actually a model which is kept here. Model 2, that is the Fourier transform. This is totally 5 modules are there, the question bank. The second module is Fourier transforms. Already the Fourier transform regarding this topic, say 11 videos already done. So now the first question is there, short answers. Now Fourier sine, integral and cosine. Just this is formula we have to recall and we have to write. Here we can see it. Remember, there is a Bloom's taxonomy action verb which is there. And whereas here the Fourier sine transform of x e power minus ax is there. So any function which is multiplied by x, separate formula is there that we have to take. The formula, defined formula taking, we have to understand according to our problem, the formula how it fits. So we are understanding. After understanding the formula straight away, we will apply into our problem. That's what here which is given also. Recalling, that is the transformations and applying the Fourier sine transform, correct formula defined one taking, we will apply to our given function. Such a way, the according to Bloom's taxonomy, 3 levels is satisfying, that is remember, understand and apply, which is prepared. Here the course outcomes are there. What are the course outcomes? Nearly 12 course outcomes are there, that which is written here. So completely part A 20 questions, part B 20, part C 10. 50 questions are there for the question bank discussion. For each module, 50 questions. This question bank which is available in the website. Now, so in the question bank, what are the definitions? The 50 questions, how much possible? Complete, what are the important points we are going to discuss in this topic? Now, Fourier integral formula. F of x equal to 1 by pi integral 0 to infinity integral minus infinity to infinity cos p of t minus x f of t dt dp. Here in this formula we have to see the to solve. We are going to, because only if it is asked that question, Fourier integral formula according to Bloom's taxonomy, remember the first level, just we will reproduce it. Now, if they are asking from which we have to derive Fourier sine integral formula and Fourier cosine integral formula, then we have to understand. So this formula also we are recollecting. That is the trigonometric basic formula. This basic formula recollecting, we are going to give connectivity to this. Then we are understanding this trigonometric formula, how it fits. We are going to do the comparison study with understanding. So according to this, here we can notice it. Here PT is there, that is playing the role of capital A, and Px is there, that is playing the role of capital B. So the left hand side which fits. Now the right hand side we will using that capital A and capital B, what they are playing in our equation, that we used it here. That is cos A, cos B plus sin A, sin B, f of t dt dp. Here we can notice it. Up to here, one integral. This is also we can write second one. So completely here, f of t dt dp, and second one, this what I am circling, f of t dt dp. So now, so the first integral and second integral. Here we are going to use the concept. We are going to test this given the integral. This is the first integral and this is the second integral. We are going to use the concept of even and odd function. So which is kept again. This function, that is cos of pt, f of t we are taking. We are going to test whether this function which is given here is even function or not. To test that, replace t by minus t we are going to substitute. That is, wherever t is there, that is replaced by minus t. So if we replace it, here we can see it, that is t we are replacing minus pt. Here also we are replacing, it has become minus t. But we know it, cos of minus theta is nothing but cos theta. So there is no change at all as it is written. Whereas this f of minus t, which is written minus f of t. So we can see here, this is the function we have taken after applying, that is t is replaced by minus t. We obtained, this is the result. That is f of x replaced by, that is x is replaced by minus x. Now we obtained minus f of x. That is just the opposite sign of what is the function we have taken. Here also the same only we are noticing. That is cos of pt into f of t. That is with the negative sign which is there. So which is an odd function. So if it is an odd function, what is the rule? Completely the function will be vanished if the integral lies between minus infinity to infinity. So according to that, this total, the function which is vanished. So the next one is sine of pt f of t. Here also we are doing replace t by minus t. So when we are replacing here sine of that t is replaced, it has become sine of minus pt. This is f of t, which is f of minus t. Sine of minus theta is nothing but minus sine theta into this f of minus t is nothing but minus f of t. This getting cancelled. So here we have written positive sign which is occurred. So here we are noticing what is the function we have taken, which is just it is replaced. We obtained the same thing even after replacing t by minus t. So it is an even function. For the even function, if the integral, the range we are seeing minus infinity to infinity, then it will be changed into 2 of integral 0 to infinity if it is an even function. So that's from which we obtained 2 by pi integral 0 to infinity sine px integral 0 to infinity f of t sine pt dt dp. So just this, from the sine integral formula we obtained Fourier sine integral formula. The same similar manner if we do Fourier cosine integral formula will be obtained. Now in this video lecture, the problems that is which are occurring in the question bank already I showed that we are discussing. So to reach the answer, what are the steps to be followed, that we are going to discuss. If we want the complete result, already regarding Fourier transform, nearly 10 to 11 videos are there. They're complete. Now we want a Fourier cosine integral formula, complete the derivation part, which is available in separate video. So what we discussed from this is the question we can expect. Write the Fourier sine integral and cosine integral. Just we will reproduce, just recollecting, recalling from our memory, we will put the answer in the paper. Just according to Bloom's taxonomy, it is the first level, remember. So now the next, these are the problems. Using Fourier integral, show that. So this is the problem which is in our question bank, that is e power minus ax minus e power minus bx, which lies on the left side. The right side we have to prove, that is 2 of b square minus a square divided by pi integral 0 to infinity lambda sine lambda x divided by lambda square plus a square into lambda square plus b square d lambda, where our a and b are positive. That's what mathematically which is written greater than 0. Now we will come to solution part, that is Fourier sine integral formula we are taking. The question which is not mentioned anything, using Fourier integral. Fourier integral is the main formula that already we have seen, from which we obtain Fourier sine integral and Fourier cosine integral. For this specifically in this problem, we have taken Fourier sine integral. The reason is what we have to prove the result. In that, the trigonometric term sine is dominating. That is the reason Fourier sine integral formula we selected. So this is the Fourier sine integral formula, that is 2 by pi integral 0 to infinity sine px integral 0 to infinity f of t sine pt dt dp. Now, this is the result to be obtained. We selected this formula. In the formula, sine pt is there, whereas here sine lambda x is there. Even the variables differs. For that, lambda we want it. So what are the steps to obtain the result? Replace p by lambda. This is the step we are taking. After taking the step, this we are obtaining. Then this part we have to do the integration. The integration purpose, this formula to be used. Very, very important formula, especially in the Fourier transform, this formula which is dominating. So the steps compulsory. The question sine is there, what to be proved. We selected Fourier sine and we are noticing lambda is there. So p we are replacing. We obtained this is the result. From here, this formula which is going to help. That formula and what is this we will do the comparison. That's what we are understanding level we are going. Bloom's taxonomy, the second level understanding. So here minus a is there, whereas in our formula a is there. And here b is there, here lambda is there. Here we can notice it. Minus a, here a is there, lambda, here b is there. So we understood very well, and the right hand side we will fill up. So we filled it, here we can see. So each problem, what are the steps to lead the solution, that we are going to discuss in our question bank. Then we can cover more problems. But if we want the complete answer, it is already done. Separate videos are available with the complete solution. So now 0 to infinity. This upper limit minus lower limit. Here we have to remember e power minus infinity, the value is 0. E power 0, the value is 1. This point we have to keep it in our mind. So here, this we replaced it, minus a. Here also, minus a the whole square, a square. Our b is lambda, so lambda square. This we can see it, a is minus a, sine bx, that is sine lambda t. That is, in the formula, that is integration with respect to x we are doing, whereas ours with respect to t we are doing. That is the reason here t is there. Compulsory we have to do the variable comparison with the formula and our given problem. Next, minus b minus lambda cos lambda t. The similar manner, this is also to be done, and e power minus infinity, if it comes, the particular place which is replaced by the value 0, e power 0 is 1. So after all applying, this is the result we are obtaining. So the first problem, the steps, these are the steps which leads to the result. So here, according to even Bloom's taxonomy, we recalled our Fourier sine integral formula. The next level we went understand our formula with our given problem. We do the comparison with understanding. Then we applied the formula completely in the problem and we reached the solution. So the third level of Bloom's taxonomy, this question completely fits. So for apply that according to that Bloom's taxonomy in the question bank, Institute of Aeronautical Engineering, the Department of Mathematics, for the subject mathematical transform techniques, the model 2 Fourier transform, which is played a role. Now, the next one is using Fourier integral. So this is the problem which is dominating in the question bank. That is e power minus ax. That is, this is the place of f of x. Our f of x which is given e power minus ax, and this to be the result we have to prove it. They told Fourier integral. So the main is Fourier integral. Fourier sine integral is there. Fourier cosine integral is there. But we are looking at the question, the cos, the trigonometric, the term is there. So, which gives an idea to us, we will go to Fourier cosine integral formula. So, that is the reason here which is written. Since the right hand side has the term cosine, we selected this cosine, that is cosine integral Fourier formula, which is written here. Same in the what to be proved, their lambda is there, replace that is p by lambda, and we will use that here we will use e power ax cos bx dx. This is the integral formula to be used. According to that, we will apply, we will do the comparison study. What is our equation A is playing in the formula? The formula e power ax by a square plus b square, a cos bx plus b sin bx. So the formula, what is a and b? In our problem, what is a and b? Minus a and lambda. So we can see minus a and lambda, they are playing the role correctly. So recalling the formula for Fourier cosine integral according to Bloom's taxonomy, and the formula also again one more integral formula. This is the formula, we recalled it, and understanding the second level we went, Bloom's taxonomy understanding, and we did the comparison and correctly understanding what is in the formula A and B, what about our problem in the place of A and B, what are the variables they are playing the role, and correctly we applied the formula to reach the solution. Here are also e power minus infinity which is equal to 0. Again recalling, remembering e power 0 which is equal to 1, remembering, but correctly we have to apply, understanding, we applied the formula to reach the solution. So the three levels which are covered in this problem. So the next one is the problem which is in the question bank. Find the Fourier transform of. So this is the problem which is dominating in our question bank, that is f of x equal to cos x mod x less than or equal to a 0 mod x which is greater than a greater than 0. Strictly which is given, that is if mod x less than or equal to a, the function to be replaced cos x. If it is greater than a, that is from a to infinity, if it is there, the function is 0. So first we have to recall, that is our Bloom's taxonomy, first level, the formula to be recalled. So we recall the formula, that is a capital F which denotes Fourier transform of the function f of x, which is equal to integral minus infinity to infinity f of x e power ipx dx. So now, what is the condition which is given in our question? That is mod x. That is a condition. So here we can see it mod x less than or equal to a. But strictly our Fourier transform formula is minus infinity to infinity. So this a should be inserted. This meaning is of this. Again we are recalling the formulas. Minus a which lies between, that is x lies between minus a and a. So with understanding, second level we are moving according to Bloom's taxonomy. This is first level. The formula we recalled and we wrote it. Next, the second level. We understood the condition which is given in our problem. That with understanding we are making to fit to our what we recalled the formula we are fitting. So the minus a to be inserted here upper and lower, and minus infinity to minus a to a to infinity. Next, this mathematical notation we have written here. Then how to read this one? This is the integration. X lies between minus infinity and minus a. But the condition which is not given in the question, strictly which is given, the f of x which lies only minus a to a only, the function exists, that is cos x. Remaining all the conditions, the function is 0, that is our condition of our problem. That we are understood. We are understanding very clearly. So the second level Bloom's taxonomy understanding is over. Next, to reach the solution correctly, we are going to apply the third level we are going to reach according to this problem. So the third we can apply in the f of x according to our problem e power ipx. F of x is cos x. This integration we have to do it. So for which this is the formula, very important formula. Complete the Fourier transforms e power ax sine bx and e power ax cos bx. They are dominating in the Fourier transform. So these two formulas we have to strongly forever we have to remember. So we are applying and with understanding this formula with our given problem. What is A and B? They are playing the role and we apply it. This is the result we applied it. Here, one more formula we are recollecting, that is recalling. This is the sine x, which is nothing but e power ix minus e power minus ix by 2i, which is equal to sine x. Next term, that is between these terms, positive, which is divided by 2 cos ax. So first, Fourier transform, we recalled it. Next, we read the question carefully. According to that, the integral minus infinity to infinity divided into 3 integrals. First and third doesn't exist. Only middle one only exists according to our problem condition. So from Bloom's taxonomy, first level 2, we have to come to second level. Then second level again, what is this integral formulas we are we have selected. So A and B, what is the role they are playing, we understood and we applied the formulas. And finally, we reach this is the result. So these are the steps to be followed. What we have to recall, what we have to understand, how to apply. So these three complete Fourier transform, 95 percentage, Bloom's taxonomy, third level satisfying questions are dominating in the question bank. So the next question in our question bank is find the Fourier transform of. So this is the question which is given. F of x equal to, that is mod x, which is less than or equal to a, 1 by 2a, and mod x, which is 0. So the solution, the Fourier transform, is Bloom's, the first level. We will recall the formula, which is written here. That is capital f of x. That is how we will read Fourier transform of the function f of x, which is equal to integral minus infinity to infinity f of x e power ipx dx. Now, how it fits to our problem. Our problem, the condition is mod x less than or equal to a. It's nothing but x lies between minus a to a. So our minus a and a to be fit in this, to be inserted in this limits, upper and lower limit. So we inserted it here, minus infinity to a, minus a to a, and a to infinity. Now we are understanding next level of Bloom's taxonomy. Understand here x lies between minus infinity to minus a. Here the function is 0. Only this function exists if x lies between minus a and a. So according to that, the function which is replaced. So 1 by 2a into e power ipx dx. The third one, the function is 0. Only the middle integral exists, and we have to do the integration. A very simple integration, we will do it, and for which after doing the integration, this formula we have to recall to reach the answer. So these are the steps to be followed for this, the third level of Bloom's taxonomy applied, for which this is the problem. Recalling just the first level of remember this, we are understanding according to our this formula how it fits, and we applied it in a correct way. Here also some aid is required, that one more formula remembering we applied, and finally we reached the destination of solution of our given problem. So next one, find the Fourier transform of f of x equal to e power minus mod x. That is the Fourier transform of f of x. The formula we recalled it, remember. And this f of x, here the limit conditions which are not given, only the function which is given in our question, just that we replaced it. But modulus, the condition, we know it. This is the condition of modulus, that is if x is greater than or equal to 0, positive, that is the positive x, and if it is less than 0, negative x. So this, we are going to recalling this modulus function, remembering the Bloom's taxonomy first level is satisfied here. Then with understanding this, we will apply here. So here this 0 is there, minus infinity to infinity is our Fourier transform limit range, in which the 0, the point to be inserted. Whether we are inserting the work in a correct way or not, yes, up, just we can cross it up and down. This is our Bloom's second level. We are understanding level. So second level is satisfied. Then Here mod x is there. Here we can notice that this is here is that 0 is there. We substituted in the mod x to the place x is less than 0. In this place, if you substitute minus x, minus minus put together positive. Here we are substituting this x, it has become e power minus x. So after substituting the formulas, we applied exponential, the basic formulas we recalled it, and we grouped this one, and the limits we have to apply. And after applying the limits, this is the result will be obtained. So the next one is Fourier sine transform. The Fourier sine transform formula, only the function which is given, they are asking us to find Fourier sine transform. For that, first recalling our Fourier sine transform formula. Yes, we recalled it. That is integral 0 to infinity f of x sine px dx. If in the question sine is there, compulsory in the formula, the trigonometric term sine px will be dominating. So this is the integral which has here we can noticing this is the function. Both they have two terms are there. Both are in exponential. So exponential and sine combination, we have a integral formula. So we are recalling that formula. And f of x which is replaced, what is a given function, we will apply. We will understand. In the formula A is there, what about in the problem? In the formula B is there, what about in the problem? Understood? We applied it, and e power minus infinity 0, e power 0, 1. And finally, we obtained, this is the result. So the steps, what are Bloom's taxonomy? Remember first level. So the any problem given, what are the formulas to be recalled for the particular problem? The problem how which is connected, the formulas which are connected to a problem in what way, then how to apply to reach the destination of solution. So totally the third level Bloom's apply, it is satisfied in this problem. So next question which is dominating in our question bank, find the Fourier sine transformation. Here f of x equal to e power minus ax by x, and deduce that. This is the question which is given. So first the which is given, function is given. We have to find Fourier sine transform. After getting some result, we have to bring this format, we need it. So very interesting problem. So Fourier sine transform, we will remember according to Bloom's taxonomy. So they remember what are the formula to be recollected. Fourier sine transform to be recollected. So we recollected the formula, and our f of x. What is our f of x? We will understand. We will move to Bloom's second level. So our f of x is e power minus ax by x. Yes, our f of x is replaced it. Next, to obtain the result in this particular problem, what are the steps we are going to focus? That is, to do this integration, this particular problem, here only this and this, the two terms are there. The formula already, so far what we have discussed it, exponential combined with the trigonometric term, that formula using we can solve easily, but this x is disturbing us. So we have to make an idea how to remove that x. This is the basic idea of to reaching the solutions. So we are understanding the level increasing. The next level we are moving to apply. Bloom's the third level applying stage, we are moving. We are taking this problem to that. So now, differentiating both sides with respect to p. So we are here differentiating. When we are differentiating, then automatically the x is getting cancelled. So the basic idea behind this, we made it the x to be cancelled. Then only we can do the integration very comfortable way, because we have in our hand the ready-made formula which is available. Recalling, we are going to apply here. So when we are doing the comparison with the formula and our given problem, what are the variables they are playing the role, and applying, we achieved. This is the result. So to reach the answer, we are doing what is the result we obtained. The last step, we are doing the integration both the sides, and the Fourier sine transform of the function which is asked in our question. This we are obtaining. Again here we are recollecting a small basic integral formula, that is 1 by a tan inverse of p by a plus c. We are substituting p equal to 0 to find this constant value, that is also 0. So we are noticing when this is a Fourier sine transform of the function f of x equal to, this is the final result we obtained it for the function e power minus ax by x. So application applied also over. Then the question, actually the question ours is e power minus ax minus e power minus bx by x. This is what which is given in our. First we have taken only this one. We obtained, this is the result. So no need to do the second part. Looking at the first part only, easily we can reproduce it. When minus a is there, p by a. If the function b is there, we can write it tan inverse p by b. Here our understanding level which is increased. So but we are noticing in the question there is no p term. S term is dominating. So we replaced completely wherever p is there. Yes, we replaced it. So this is the way we achieved the result. So the next problem which is dominating in our question bank is find the Fourier sine and cosine transform of x. So we are recalling our Fourier sine transform formula, and we understood our f of x should be replaced by our function. Yes, we replaced it, and we have to do the basic that integration technique. Here the question of Fourier cosine also which is given. So Fourier cosine formula, we have recalled it. F of x which is replaced by x. This is very interesting actually, this problem. Like this, if you are integrating also we can do it. Here also we can. But both put together, Fourier sine and Fourier cosine, we don't want to do two times separately. The basic idea, we want to introduce gamma function here. So recalling gamma function, how we are going to apply in this particular problem, especially is a very, very interesting problem using gamma function. This can be done like this, expanding also this can be done. Otherwise, now what we are going to discuss, gamma function using also, we can find the solution. So here we are noticing here sine and cos put together, we have put the notation e power minus ipx. This completely x term is there, that we are going to, instead of x, completely we are going to the substitution method. In terms of y, we are going to change, for which we have taken ipx equal to y. Then we are doing the differentiation. Here we are noticing this x is there, from which we extracted the x. So it's nothing but y by ip, and e power, here we are noticing minus ipx. What we here, ipx we assumed as y, so minus y. The dx, it's nothing but from here we can obtain dy by ip. The basic idea is we want the format of gamma function. So the gamma function format, we will bring this problem and we obtained, this is the result. So real part, we will, this expansion of vector, the real part we will do the comparison. Imaginary part, there is no imaginary, there is I term only, it is not there, so which is equal to 0. So all completely the problems, what are the steps, important steps that to reach the solutions that we are discussing, what are the first level, what are the formulas to be recollect, remembering the formula how which is connected to our problem, understanding, then finally applying, we are reaching the solution complete in this video lecture. So the next problem which is dominating in our question bank is find Fourier cosine transform of the function f of x equal to e power minus ax cos ax. That is the given function, if you are noticing, f of x equal to e power minus ax cos ax. So we recalled the formula, that is Fourier cosine f of x, we have taken integral 0 to infinity f of x cos bx dx. So this f of x, it's nothing but our equation which is written here. So cos bx dx. The trigonometric formula we are recollecting. Whenever we will, when actually the time correct the place to be recalled the trigonometry, a beautiful concept. The trigonometric terms under product, or if the trigonometric terms, if they have power, then this formula to be selected. So first formula we are, so remembering the first level Fourier cosine, next trigonometric formula, third this. So this slide only the three formulas we recollected. So Bloom's first level. The second level, we are going the connectivity with understanding, and this to be applied it. So after applying, and the limits also upper and lower limit, substitution doing, we obtained, this is the result. So three levels, completely this question bank of the problems for your transforms, 92, most 90% apply, three levels Bloom's satisfied. So the next one is find Fourier cosine and sine transform of, this is the function which is given, and deduce the inversion formula. That is first the function we are writing. This is the formula we recalled it. That is our Fourier cosine. Again, so already I told very the starting onwards. This is e power ax sine bx, e power ax cos bx. These two formulas will dominate in Fourier transform like anything. So after applying, this is the result we obtained it. But this beautiful problem, they didn't ask for the function. Our function is e power minus ax. They didn't ask not only us to do only Fourier cosine, from which they asked the part inverse also. So very, very careful we have to be. When we are doing the inverse, the function will be out. What we found a Fourier cosine, which will play the role under the integration. And one more thing, we have to do the integration with respect to p for inverse. This point also to be noted very carefully. So after substituting here, this is the one we find it. We already know it. What is our f of x? That is, we are replacing it. Some simplifications we have done it. Just the 2 pi, we brought it to the next side and we obtained the result. So the same way, Fourier cosine we did, the same problem, Fourier sine, the similar steps to be adopted. and this we will obtain it. And inverse Fourier sine also, the formula to be replaced it here, which is there. Same, the simplifications done it in the similar manner, we will obtain the result, that is pi into e power minus ax by 2, which is equal to integral 0 to infinity p by a square plus p square sine px dt. So the next one is find inverse finite Fourier transform. So here we can see it, f of x. There is a Fourier transform which is given here. This is not there. There is Fourier sine which is given here. Here equal sign not there. So we are recalling the formula inverse finite sine Fourier transform. This is the formula summation. We have to be very careful to remember while recalling the formula some sort of technique, that is while inverse finite, when we are recalling the formulas, summation symbol will dominate, and n pi x by L, length of the interval will be. Now to L here also is there, here also L is there. In the question, x, actually according to the formula, x lies between 0 to L is the formula condition. So our L, which is playing the role, pi. So wherever L is there, we will replace it by pi. So replace it. This is nothing but in the question itself which is given. That we replaced it. Pi getting cancelled, the balance which is written. Very simple. So the next which is dominating in our question bank, find the inverse cosine transform. So here the Fourier cosine which is given, we have to find f of x. X lies between 0 to 4. According to formula, x lies between 0 to L. So our L is 4. Now we are recalling our Bloom's taxonomy, the first level, remember. So we recalled the formula and we are understanding, that is Fourier cosine, which plays a role under the summation. Then what about in our problem, what is given? Fc of n given, correctly we are applying in the particular place. And what about L? In the formula, L is there. Our given condition, we are understanding Bloom's second level, understanding our L is 4. The third level, apply. Wherever L, we will apply 4. 1, 2, 3. We applied it in a correct way. So these steps to be followed to reach the solution. The next question which is dominating in our question bank, that is find the Fourier transform of f of x, which is equal to a square minus x square. That is if mod x which is less than 0, this is the function, but whereas mod x is greater than a, the function is 0. So more they asked that this finding the Fourier transform, we have to show this result also, for which first we are recalling the Fourier transform formula. So formula which is written here, and according to our condition, that is minus infinity to minus a to a to infinity. The first and third integral, they are vanished according to our problem condition. Only the middle one only exists. These two formulas are which while solving after this integration, this is to be obtained, for which these formulas recalling we are going to apply in this. After applying, so Fourier transform of the particular function, this is the result will be got. So the formula is Fourier transform of the function f of x. It's nothing but these are the steps to be adopted for this particular problem. So now deduction, they asked has some part of the question more extension is there. for which mostly if any extension is there, better after completing the Fourier transform, inverse formula to be selected. What we obtained in the Fourier, which will come under integration. So we can see it here. This is the inverse Fourier integration formula. Now what we obtained, that will be substituted in this particular place. So after substituting, we will use the concept of odd function and even function. This is also the earlier class we discussed it. Using those concepts, we will obtain this result, in which a, wherever a, we put it 1. This is f of x, it's nothing but the function which is given in our equation, a square minus x square. So a plus we are putting 1, here also 1, 1, 1. Then this is the result we obtained it. And put x equal to 0, because the question which is given show that this is the result they are asked us to show. So finally we reached it. So for that, to get the show that, to obtain that result, only a equal to 1 and x equal to 0, we substituted those values in the particular places. So next, finally more actually we want to the character result. What is the result to be obtained? There is no p term you're finding, only x is there. Better wherever the p, we replaced it by x. So now, the completely we discussed about finite and infinite Fourier transforms. Then some important properties are there. That is, if capital F of p and g of p, the two Fourier transforms, that is our f of x, which is related to our f of p, and g of x, which is related to our capital G of p. Actually, the basic concept of our Fourier transform is Fourier of first and second two functions are there. That we can write it Fourier of first function plus Fourier of second function. The constants will be written outside. So for which first f of p we are taking, we are recalling the formulas of Fourier transform for the functions f of x and g of x. So here this is our given function. So in the Fourier, what is our function? That is, we replaced it. And this one integral, this is next integral. So this two terms are there. We are going to write two integrals. So the first integral and second integral, we know it, this is nothing but the formula Fourier transform. So the same we can write a f of x also we can write, nothing wrong in it. In short form, another notation, capital F of p also we can write it. So throughout in this video lecture we can notice it. For the infinite, that is, we used the notation p, that is, infinity will dominate infinite. For the finite, the notation n we have taken. That is the most of the textbooks. These are the notations all referred. So p, this is nothing but g of p. So the Fourier transform, that is of two functions, can be written as a Fourier transform of first function plus Fourier transform of second function, which are each they are multiplied by constants. So this for linearity property we applied for Fourier. Same we can apply it for even Fourier cosine as well as Fourier sine and cosine. For both we can apply it. Next, the thing is a change of scale property. That is, if capital F of p, if you are taking, is a complex Fourier transform of f of x. That is capital F of x, which is equal to 1 by a. That is, if instead of the function, if it is x, only f of x is there, the Fourier is capital F of x, otherwise another notation, capital F of p. But instead of x, suppose ax if it is there, then the change of scale property is 1 by a, capital F of p by a. where a is greater than 0. This is our change of scale property statement. The next one is shifting property. The shifting property is if capital F of p is a complex Fourier transform of f of x, then the complex Fourier transform of if it is f of x, then f of p is a Fourier transform. Suppose instead of x, if it is x minus a, then Fourier transform which is multiplied by e power ipa, that is our shifting property. We have to recall the formula. This just only recalling is our Bloom's first level. The second level proof we will understanding, we will apply it second level. And what are the formulas recalling and a comparison with the formulas and a given statement conditions, it will reach the third level. Next, the property regarding our Fourier transform. These are the properties which are dominating in our question bank. That is, the modulation theorem is if capital F of p is the complex Fourier transform of f of x, then if f of x cos ax is there, that is f of x, if it is there f of p, instead of f of x, if the function is f of x cos ax is there, then the result will be 1 by 2 of capital F of p plus a plus capital F of p minus a. So this we can see it, just we will recall Bloom's the first level formula recalling Fourier transform formula is capital F of x, which is equal to integral minus infinity to infinity e power ipx f of x dx. So this is the formula which is written here. Next, our f of x, which is replaced by f of x cos x. What is our function? That is a problem function which is replaced in this particular place. So we understood the second level, we moved to understanding. The next thing, one more formula we are going to recollect, that is cos ax, we are going to replace by the particular formula. This is why we are selecting this particular formula. That is the second level of Bloom's taxonomy. Then only, because we have to obtain the result, the modulation theorem result, for that with understanding the corresponding the formula we have selected, and in the particular place we substituted it. So the next one is, here we are seeing this and this both we are multiplying, and this and this we are multiplying. So here we are seeing two terms are there. In the two terms, here we can see it, the integral also to be written to the first integral and the second integral. So here the first integral and the second integral. And we know the exponential law. That is, according to the exponential law, we can notice it, the terms, or we can add it. Here also these terms to be added. When we are adding here, we are noticing ix is common. Here also ix is common. So on that basis, using the basic exponential formula, recalling that we modified the steps we followed it to reach the solution. So next one. So here integral minus infinity to infinity e power ipx f of x dx. If it is like this, then we will tell capital F of p is the Fourier transform. But here x is there. Instead of p, here p plus a is there. So we can write it capital F of p plus a we can write. In this particular place, what is there? Instead of p, here p minus a is there. So capital F of p minus a. So now, this is the question which is dominating in our question bank. That is, capital, that is a Fourier sine transform of if our f of x, which is multiplied by x. The log procedure is there. The Fourier sine transform formula recollecting, we can apply it. Instead of that, this is the way also can be done. That is a first derivative of Fourier cosine with a negative with opposite sign. Both the result will be same. And one more also, this is specifically it should be applied, that is a Fourier cosine of the function f of x if it is multiplied by x. That is nothing but the first derivative of Fourier cosine of p. So the next one, find the finite Fourier sine and cosine transforms. Here we can say f of x equal to 2x, x lies between 0 to 2 pi. So the finite Fourier sine transform formula is, we can see it capital F S of f of x. For the finite, we are using the notation m. So capital F S of m, which is nothing but integral 0 to L f of x sine of n pi x by L dx. Integral 0 to, we are comparing x lies between 0 to L, so x lies between 0 to 2 pi. So L place our problem 2 pi, which is dominating. So 0 to 2 pi. F of x, which is replaced by our given problem function, that's 2x. So sine of n pi x by L, which is replaced by 2 pi dx. So here the pi, they both are getting cancelled. We obtained it. Integral 0 to 2 pi 2x sine of nx by 2 dx. This integration, it's a very interesting the way we can do it. Here the 2x is there, the algebraic part which is written here. The algebraic part we will be going on differentiation. Whereas the trigonometric one, if you're noticing, sine of nx by 2. The integrated one we will be writing first, that is sine of the term. Sine, the integration is minus cos of the term. So minus cos of the particular term. The particular term which has, again we have to do it, the coefficient of x. But n, x both are there. Why specifically we have to take x? Because we did the integration with respect to x. So the coefficient of x, it's nothing but n by 2 divided by n by 2 to be done. So very interesting way. This algebraic one, we will be going on doing differentiation, and we stop the procedure here because the constant of the differentiation is 0. So that is the reason we stopped here. The trigonometric one, we will do the integration one. The integrating, and we will be writing here. Then again this integration, that is minus is written as it is, cos of the term, that is sine of the term divided by n by 2. So n by 2 into n by 2, n by 2 the whole square. So 0 to 2 pi. Before substituting here the one, to avoid the careless mistakes, we can adopt this step. Before the substitution of upper and lower limit, better the first term, here positive is a negative, we will make the terms as single sign. Here also negative, negative, we will make it positive, and we will do the substitutions. So here that the last step, that substitutions, actually we can notice it here. That is the 2 square is the n square by 2 square. When it comes up, 8 by n square. Here also we can notice it, n by 2. This minus, it has come out, minus 4x by n cos of nx by 2 plus 8 by n square sine of nx by 2, 0 to 2. So the upper one, that is in the place of x, we will substitute 2 pi. So cos of 2n pi, it's nothing but 1. So here x is replaced by upper limits 2 pi, This is the result we obtained it. This is a upper limit formula. This is a lower limit formula. Middle, the negative sign that is related to our limit formula sign. Upper value in the place of x2 pi dominated. In the lower one, in the x place, the dominated, the value is 0. Finally, we obtained the result minus 8 pi minus 1 power n divided by n. More if you want to do the simplification, here negative sign is there, that we can write it minus 1. Already minus 1 power n which is there here, put together minus 1 power n plus 1. So in this problem, first we recollected the formula and we gave the connectivity with the understanding, and middle also some basic exponential formulas also we recollected and we applied to reach this solution of our given problem. So the same actually the question which is asked not only Fourier sine, they asked Fourier cosine also. So the Fourier cosine formula is f of x cos of n pi x by n dx. The similar way this can be done. So now we will come to a conclusion of this topic, Fourier transforms. First, Fourier transform. What is actually Bloom's taxonomy? How it is connected to that? Fourier transform, inverse Fourier transform, infinite Fourier transform, finite Fourier transform. Completely the question bank, the questions 90% Bloom's taxonomy, third level applied. On that basis, it is framed. And we discussed the Bloom's taxonomy. The first level is, remember, to recollect, to recall the formulas, how they are connected to the formulas to our given problem, understanding level. The next, the third level we reached, apply. In the Fourier transform, what are the formulas? Fourier transform, integral minus infinity to infinity, e power ipx f of x dx. Fourier transform, if it is there, then with respect to x, we will do the integration. Whereas inverse, if it comes with respect to p. So we increased our understanding level according to Bloom's. Second, infinite Fourier transform, the formula which easily we can understand, integral minus infinity to infinity, Fourier transform. Whereas Fourier sine, integral 0 to infinity, and integral 0 to infinity. If it is Fourier cosine, then cos, the trigonometric term, will be dominating. So the main actually the Fourier transform we obtained from Fourier integral theorem. That from Fourier integral theorem, Fourier sine integral we obtained, Fourier cosine integral we obtained. Finally, we discussed about the problem. These all the problems which are dominating in the question bank, the second module, Fourier transforms. That finite Fourier transform, their x lies between 0 to L, which is finite, towards that Fourier transform which is connected. That is also we discussed in detail. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.